Alright, so today we're going to be going over the derivatives of trig functions, in which there are some few important rules to know for derivatives with trig functions. So sine of x, d over dx is always cosine x. The derivative of cosine x is always negative sine x. The derivative of tan is always secant squared. And then secant is secant times tan. And then the derivative of cotangent is always negative cosecant squared. And one thing you haven't seen here is cosecant x. So the derivative of that, it's not really asked that much, and it's not knowing it or memorizing it rather won't be as useful really as these other 5 rules. Alright, so we're going to try these few questions. So we're going to try everything on this page except number 5, number 7, and number 9. So let's take a look at number 1. Number 1 is function x, 3 sine x minus 2 cosine x. For this, we'll just find derivative of these independently, which 3 sine of x will just gives us 3 cosine of x, minus 2 cosine x, which is derivative is negative 2 sine of x. So that'll be 3 cosine x minus negative 2 sine of x, which 2 negatives is positive, so 3 cosine x plus 2 sine of x would be your final answer. Now number 2 is function x, tan x minus 4 sine of x. So we would find the derivative of these independently. So tan x, the derivative of that is secant squared x, and then minus 4 cosine of x, because derivative of sine of x is cosine. That would be your answer. And number 3 is x squared plus cotangent x. So again, independently, so x squared, derivative of that is 2x, plus cotangent, derivative of that is negative cosecant squared x. And that would be your final answer. So for number 4, you see we're dealing with a negative cosecant. So derivative of a cosecant, even though we don't really use it much, is derivative of cosecant will give us negative cosecant x multiplied by cotangent x. So if we were to answer this, 2 times secant x, derivative of secant x is secant tan. So we would get 2 open parentheses secant x times tangent x, and then minus derivative of cosecant x, which is this right here. So it would actually be plus, because 2 negatives, plus cosecant x, and then minus cotangent x. Is a little bit jumbled here, but basically 2 secant x times 2 tangent x plus cosecant x minus cotangent x. That would be your final answer. Number 6 is g of x equals 3x plus x squared times cosine x. So 3x is pretty easy. A derivative of that is 3. And then for x squared times cosine x, we're going to actually have to use the product rule, in which the product rule is f times g is f g prime plus f prime times g. So in this case, f is going to be x squared and g is going to be cosine x. So we're going to do plus right here. So f is x squared, g prime is sine of x, negative sine of x. We'll do open parentheses here, negative sine of x, and plus f prime, which is 2x, times cosine x, which is g of x. And that would be your final answer. Now number 8, we're also gonna have to use a product rule here for sine theta and cosine theta. So again, product rule, f g prime plus f prime g. So f is going to be sine, g is going to be cosine. So we have sine theta times g prime, which is cosine, derivative of cosine, which is negative sine theta, and then plus f prime's derivative of sine is cosine theta, and then times g prime, which is, or rather g, which is cosine. So if we just write it out, it would basically just be negative sine squared theta plus cosine squared theta, because they're both multiplying by each other. And that would be your final answer for number 8. So now we move on to the number 2728, which is find the equation of the tangent line to the curve at a given point. So for number 2728, we're just going to find the derivative, plug in the x value to find the slope of the tangent line equation, and then we're going to find the y value of the tangent line. So for number 27, sine x plus cosine of x, the derivative of that would just be cosine of x minus sine of x. So now what we do is we plug in 0 for the x value. So we do cosine 0 minus sine 0. So we know cosine 0 is 1, and then sine 0 is 0. So 1 minus 0 is 1. So we could say y equals x, and then we need to find the b value. So we know the point crosses through the y value of 1 at 0, which means that the b value must be 1 because that's the y value when the x value equals 0. So the equation must be y equals x plus 1. And that would be your tangent line for 27. And for 28 is y equals x plus sine of x. So if you find derivative of that, we would get 1 plus cosine of x. Now we have to plug in pi for x. So we plug in pi to find the slope. We get 1 plus cosine pi. And then, so we know 1, and then plus cosine pi is negative 1. Because if we do remember on a cosine graph, at the x value of 1, cosine graph starts here, and then at pi it reaches down here, and then 2 pi it goes there because the period is a pi. And the amplitude is negative 1 just by the sine normal or cosine function. So 1 plus negative 1 is going to give us 0, in which the slope is 0. So we could do y equals, we know the line goes through the y value of pi on the x value of pi, so since there's no slope to it, we could just put y equals pi. And that would be your tangent line for the equation, in which this is showing that the line, tangent line of the derivative of this is going to be a horizontal line on the y value of pi. Alright, so I want you guys to try number 11, number 12, 13, 15, and number 18. So you can pause the video and try that. Most of these for like this one, you use the quotient rule, and then this is a product rule, most of it, and then this will be the chain rule. So you can try those out. Alright, so number 11 is function h of t cosine squared t. So we're going to use the chain rule. The chain rule is essentially f prime in parentheses function g of x times g prime of x. So if we use the chain rule, we're going to get 2 cosine t, that would be f prime g of x, multiplied by g prime of x, which is just cosine, which would be negative sine x, or negative sine t rather. And that would be your final answer right there. Number 12 is e to the power of x sine x plus cosine x. So for e to the power of x plus sine x, we're going to have to use the product rule, which is fg prime plus f prime g. A good way to remember these rules is just write it out as soon as you read the question so you don't make a mistake. So f times g prime is going to be ex cosine x plus f prime, which is still e of x, e to the power of x rather, times sine x, which is g, and then plus derivative of cosine x, which is negative sine x. And now there are no like terms really to add together, so this would just be your final answer. Now number 13 is sine theta over 1 plus cosine theta. So we got to use the quotient rule here. So the quotient rule is f prime times g minus f times g prime over g squared. The over g squared is really important not to forget. So sine theta, so f of x is on the top, g of x is on the bottom, so the derivative of sine theta is going to be cosine theta, or rather I'm just going to write cosine and sine instead of the theta as well, and then multiplied by g, which is 1 plus cosine, minus f, which is sine, multiplied by g prime, which is just going to be negative sine, and then that's all going to be over g squared, which is going to be 1 plus cosine theta squared. Now if we simplify all that together, we would get cosine theta plus cosine squared theta minus, that would be minus negative, or rather plus sine squared theta over 1 plus cosine theta squared. And then the bottom, usually we don't need to simplify it out because it would not help us in deriving the answer, so we just leave it like this. And now number 15, we also use the quotient rule, f prime g plus fg prime over g squared. So first is f prime, which is x, f is on top, g is on the bottom. So x, which is 1, times g, which is 2 minus tan x. Handwriting's really taking a toll here. Now, oh yeah, that's minus. I forgot to write that. I didn't get that wrong in the previous question. Minus there. And then f, which is x, times g prime, which is going to be secant squared x. And then on the bottom would be 2 minus tan x, and that would be squared, in which we don't need to simplify that. So you could leave your answer just like this, 1 minus, or that 1 times wouldn't matter really, 2 minus tan x minus x secant squared, and then on the denominator would be 2 minus tan x squared. You could just leave it like that. That would be your final answer. And then number 18 is sine t over 1 plus tan t. So for this, we use the quotient rule again, f prime g minus fg prime over g squared. So f prime is going to be cosine t times g, which is going to be 1 plus tan t, and then minus f, which is going to be sine t, and multiplied by the derivative of 1 plus tan t, which is going to be secant squared t, and all of that is going to be over 1 plus tan t to the second power, in which we don't have to simplify this either. You could multiply out the numerator to like make it all, similar terms and whatnot. But you could always leave it like this, simplify it out, but the denominator, you rarely ever have to simplify it unless you could simplify the whole thing out. But otherwise, you could leave it like that. So, yeah. Alright, so that's basically the derivatives of trig functions. So, There's some important things to know about with the formulas and whatnot. Sine x, cosine tan, cotangent secant. The cosecant derivative could also be important sometimes. Usually it doesn't show up on like homework or test really. It's one of those derivatives that don't get used. But just memorizing the derive, what these trig functions derive into is a good way to just ace the trig functions and just be able to get through a question smoothly. So yeah, it's basically it.